Well, it was a December to remember, and some of you that were in the shop know what I'm talking about. We're back on the Nurila Glacial aircraft, and of course it's really hard to miss the ginormous F-15 we got in the background that just showed up too. So man, we got a lot of cool projects for 2025, and a lot of them were delayed. They're just starting to roll through, so we got to get things like this wrapped up. Welcome to video 3 in the series. We're continuing on where we left off. We left off with getting, last video, got our wings mounted, our horizontal stabs kind of roughed in, mounted, control surfaces done for the rudder. So we're just going to continue on with progress. Let's see where we go. Let's dive back in. And you know, I don't really know if it's possible to do this much growth in 1 year, but if you happen to be watching this video and you look down and you're not subscribed to the channel, please hit that subscribe button down below. It's free to do so. We're trying to get to 100,000 subscribers. As of recording this video, I think we're at like 54 or 55,000. We got a lot of room to make up, but I think it's possible if we really push through and do it. So hit that subscribe button down below, and we got so many cool projects coming up. So last video, I believe we just got our horizontal stab stuff glued in here. So I'll show you guys this. We'll do a little bit of a recap, but basically we got our anti-rotation adjustment pin installed, so that's done. Our Delrin bushings here have a nice grab at about the 50% point on that guy, so there's a mark right there, which is right around the midpoint, which is great. And our carbon tube here, which fits nicely into the receiver. So the important thing that I want to cover here is I've seen some guys, this is just pictures on the internet, I've seen some guys do the fastening screw through the top, and I'm assuming I've seen other guys do it through the bottom because it's not visible on the top. But the top is the better way to do it, and the reason that's the better way to do it, and I think I might have covered this before, but I can't remember. So this is the top side here, bottom side there, but if you look, you've got a piece of structure in there that's about probably 6 to 7 millimeters in between the tube and the skin. And on this side, you've got about a 2 to 3 millimeter piece of structure in that area. And now the tube, the phenolic receiver tube, is also angled. So what happens is, as it gets closer to this end, where we're actually going to fasten it, it actually gets really close to the skin here and even further away there. So it makes so much more sense to attach that with a screw into the tube through the top side. And that's the way we're going to do it. Okay, so a couple of things here. We're going to make sure we measure this 10 times before we do any drilling. But if you, Lassie from Nurila says if you hold this up to a bright light, maybe this isn't bright enough, but I can see the end of the carbon tube right there, or at least the structure that the carbon tube sits against. So we're going to do a whole bunch of measuring on this, measure 10 times, and obviously get our spacing centered. There is stops built in to the receiver tube, so that carbon tube's only going to go in so far. So what I'm going to do is I'm going to pull that other horizontal stab off. We're going to take this carbon tube, get it installed all the way, make a mark, do the same thing on the other side, just so we have a visual representation here of how far that tube sits side to side, and just check and make sure it's even. All right, last video I talked about all of our supplies that showed up from F3a website. Can't remember the website name, but yeah, the F3a website. So we've got a bunch of stuff in there, but also needed to pick up a incidence meter. This is something I've never owned, but I found one. This is actually very difficult to find, and I found a supply place that had one in stock. So I picked it up, and this is going to be very useful when we set this plane up. All right, so a carbon rod we marked right and left on the ends, and we installed the carbon rod. I just took a paint marker and just drew a line around the perimeter. So we did that on the same thing on both sides. And the reason for that is now we know roughly where our center mark is. So if we take that and give it a twist. You can see just a little bit of the paint marker showing. So if I make that side disappear, then we're pretty much even on that side as well too. So as soon as that paint mark disappears, we know we're centered. Took a felt marker, installed that just so I can get the position, the angle of this, put a piece of tape down just so I can draw reference lines on there. And now what we can do is we can take our calipers and we can measure the end of the carbon tube from the edge of the wing surface here. So we'll make a mark on the tape so we know where our furthest out point is. And we'll do that on each of the surfaces. All right, so I'm going to take my calipers, I extend them and get them bottomed out there on the end piece. We're basically sitting at about 81, 82 millimeters, and we're exactly the same on this surface here. So I just went to the bottom, extended it a little bit so we're touching the edge. So now we've got a measurement here of where the end of our carbon tube is. On the actual surface of the skin, we can mark it. All right, so now we've got a visual representation of where that tube ends, and just to show you what I'm talking about here, so if I put the Sharpie in there and just mark it with my thumbnail and hold it up there, you can see where that tube, receiver tube, phenolic tube actually ends. And if we look down the actual tube like this, we can get a really good idea of where we need to drill that hole. So that gives us a great idea on where to put the hole. Now when I did the piece of wood or dowel in the end here, I didn't do a super small piece, so it's not like I have to stick within the end, the last 5 millimeters of this tube. You know, we've got a ½ inch, I can't even remember the size, but it's a reasonable size piece inside there. So in a situation like this, I'm quite confident using my eyes to get this done, but I look down the tube and without looking at the tape where I'm marking this, close one eye, and I basically took my Sharpie and just drew a line right down the center of the tube while I was looking down the tube, and that's what we end up with. So obviously we want to stay away from that end point, and it gives us a center line here to do our lines on, and that's what the other one looks like. So in a situation like this, you want to get the one side done first. That's an important thing, and you want to do your hole in here first, or you want to do the one side together first, because you need to get this side of the tube fixed in one side of your elevator so you can get all of the systems squished together nice and tight. Ideally, when I do these, I'm looking for those screws to kind of suck everything in nice and tight. You don't want this to be loose where it's pushing the surface out away from the fuselage. That'll create gaps in your fuselage. So a couple important things. That's all stuff I've learned from turbine aircraft as well, but very transferable to situations like this. So I'm going to peel some of my base tape off just so it's not in the way. And now we can work on getting this one side done first. So this is where the incidence gauge comes in. So if you think about this, you don't really have independent control of the incidence on the surfaces separately. Reason for that is if you get this surface screwed through the carbon tube and you get the other side screwed through the carbon tube and they're not perfectly level from the get-go, you're going to have an issue because you can't do your corrections on only one side. They have to be done on both sides at the same time, because as this one turns and twists that tube, I mean, you're talking about small amounts, but as it turns and twists that tube, the other side's going to want to do the same thing. So we need to get these surfaces, first of all, set to be exactly the same. Or we'll do this one first, get it all set and ready to go, and before we drill that other side, we're going to get the incidence match. So that's how we're going to do this, and that's an important step. All right, so the screws we're going to use in this scenario, because we put some wood in there, I'm going to use some of these small panhead screws. These are beautiful for this application. So first side, left side, we've got the tube installed, and we're going to drill this out as a system. When we do the other side, that's when it gets a little bit more specific. So I'm just going to use my drill. We'll come in here probably 5 millimeters from the end, and so right at the end of the ruler right there, and we'll drill our hole right in that location, which should be perfection. So first one, we're really not worried about it at all because the position doesn't really make a difference in the tube and all that. So the only thing that really matters is we get our hole nicely done. I'm just going to double check that. So we're going to come in a little bit further maybe, just to be 100% sure. So we're just going to follow the line. We'll come in about 7 millimeters. And just taking it nice and easy. Now I don't want to go all the way through, but I want to make sure we're nice and solid. Obviously we're going into the carbon right now. And once we get through the carbon, we'll see our wood. There we go. So now we're into our wood, so we'll pull that out. And there's our hole. So I'm going to finish that hole with my drill bit. We're going to get the screw put in there to get threads, harden it up with some CA. We're going to take the tape off, probably harden the skin up just a little bit because there's foam in the skin, just in that area to make sure that we've got some good bite. But you are going through the phenolic tube inside the surface as well too, so it should be nice and strong anyways, but we're going to get this ready to install in there. All right, left side's all installed. We don't go too tight on the screw. We just snug it down. Just starts to squish the skin a little bit, but if you go too tight, you're just going to damage the skin. Now, there's really no way to line this up on this surface other than, you kind of get, before you put it in, you get the hole lined up. We know that when we tucked it all the way in, that's when the holes line up. So that's pretty straightforward. And then when we get this installed on the fuselage, squish it all together and get our holes done properly, that's when the other side's going to line up perfectly. So those are some of the intricacies of putting this plane together. So anyways, what we do now is we're going to get this installed, the surface installed in the fuselage. So really nothing special at this point other than once we get the other side installed, we need to make our incidence match perfectly. That's the key. So our front incidence pins right now are loose. So we've got a little bit of play there, which is fine. We're going to get those matched up here shortly. Now the incidence, the actual number of the incidence right now doesn't matter. What matters is these two guys end up matching. That is the key. All right, so this is when things get important, and this is where you use your screws to suck everything in. So you can take this surface, and we could just randomly drill our hole, and you may end up with a gap here, which is no good because the surfaces are going to be wiggling side to side. So that's what we're trying to avoid when I do this. So when I do these types of holes where you've got the screws going through the wing tubes, we want to make sure that our surfaces are nice and sucked in tight. We're going to drill our hole, and then we're going to offset the hole a little bit towards the center line of the fuselage, and that helps suck everything in together. But the first thing we need to do is we need to get our incidence between these two items set. So we've got a little bit of play on both sides. So we're just going to get these guys fastened down, and then we'll get our Robart incidence meter out, and we're going to check these guys to make sure they match. All right, so we've got our incidence meter installed. Again, it really doesn't matter what the actual number is. All that matters is matching them up. So we're about 2.5 on the incidence meter. And I took my digital protractor and installed that on the bar. And you can see there we're 2.3-ish. So that gives us some good reference for angles. So now what we'll do with this set and fastened is we're going to get our other side matched up to this side, and we'll confirm that multiple times before we do our other fastening side. All right, so we've got everything set up on the other side, the other horizontal stab. We've got that to almost the same spot, and I take my digital protractor. Now I zeroed this out on the other one. So of course, if we flip this around, we're measuring some weird angles, so 5.5 degrees, but that's because we zeroed it out in this position like that. So if I take the digital protractor, put it on this side like that, and we are bang on 0.00. So now both of these horizontal stabs are in exactly the same position. We've got our rotation fastened at the front, so it's not going to move at all. And now with those set, we can now drill our other fixing pin or screw that goes through the carbon tube. And just in case, you can also do a visual as well too from the rear of the aircraft or the front of the aircraft. You know, you can do that as well with your eyes just as a double check, but I trust our double instruments that we've checked it with and everything looks great. All right, horizontal stabs are done. This worked out exactly how I wanted it to work out. So once we got the incidence all set, happy and everything, we drilled this hole. Now when I drill this hole, I drill it at an angle. This hole is too small, it's a 1/16 drill bit, so we drilled it at an angle like this. Once I was through the actual surface tube into the wood and felt it stop before it punctured the carbon on the other side, pulled the surface off, and then I increased the size of the hole by holding it vertical and going towards the center line of the fuselage. So what happened, as soon as we put that screw in, sucks all this in nice and tight. So that's a great setup. Now when you take these things on and off, if for transport if you are, all I would do in this scenario is loosen the top screw, because those are holding them in place. So loosen the top screw, whatever, half a turn, quarter turn. This surface is going to slide off once that screw comes out. And then when you put it back together, you're just going to snug this guy up. Your bottom one is actually going to hold it in the right position, and that can be the same thing on both sides. So horizontal stabs worked out great. The other thing I did here was obviously check it with your eyes. Your eyes don't lie, I say that very often, but if you look at the top of the surfaces there and just bring your head down and you're comparing the two sides, you can see when those things are level with each other. And you know, all the measuring tools that you have are great, but if you got good eyes, it's really hard to fool the eyes. All right, so we've got our horizontal stabs off. Next thing to do is to get our servo slots done up, horns mounted, all that stuff. We did a little bit of sanding on the tube here to get rid of the little bump and put a drop of thin CA in each side. So tube is good, ready to go. So the kit comes with some decals, stickers to put on the back here, which are these guys right there. So what that's going to do is that's going to give us our servo opening slot, which lines up perfectly with our servo mount and also gives our control horn slot there as well too. So we're going to get these decals installed on the surfaces, and I'll show you guys anything fancy with that. All right, that was incredibly easy to put together. I got them on the first try, which is good. So we're going to get these things routed out. We're using our Dremel, so we'll use our small little 1/8 bit for the servo opening, and then I'm going to use the circle discs to do the servo pocket. We may have to do a little bit of manipulation with that, but at least we're going to get the pocket done, and then we'll figure out how deep we need to cut that material out. So we've got our slots cut here. I went a little bit shy on the openings, and just because we don't need them to be that big, and I also want to be able to adjust them if we can. So I'm going to leave the sticker on there, but we've got that done. Now the HV69 is a wicked little servo. Downside with it is, well, it's light, first of all, that's a positive. But downside is these pockets are built for mini servos like the 747, but you get so much torque out of these little servos, and they're much lighter as well. So we're going to have to skew that servo forward a little bit. So we're going to tuck it up to the front of the opening, and then you can see we've got to fill the back side of the opening, but that actually works out good. So we can put a little piece of ply in this back section. We can put a strip in the front section. That's also going to space out our servo to be just right with the opening that was cut and the control arm and horn and everything. Now these horns, we've got a few different options in the kit. We've talked about this previously. I'm assuming that these four that match are for the ailerons, so we'll keep those for the ailerons. And then we've got these guys here, which would also pair up with those, but we can use these two for our elevators. Now, in its stock format, these are actually, there's enough room in there, but I'll probably end up just knocking these little tabs off so we don't need to get rid of material too far into that actual elevator surface. But these are how those guys are going to fit in there. So we'll tuck these all the way forward just like that, and that brings our hinge point here or our control horn mounting right over the hinge line, which is again perfection. So happy with that. Just need to be a little bit careful getting the material out of the elevator surface. All right, just kind of got things mocked up here, and it looks like we actually don't need to space that servo out at all, which is great. So we've got one of the KST aluminum red arms installed on there, and it is bang on center in that pocket. And also if we get that servo kind of fastened down, line it up with our eyes to our slot here for our horn itself, it's bang on perfect. So what will determine if we space that out or not is going to be our hardware. So we get the most amount of options if we line the center line of these two devices up with each other. All right, there's a shot of the servo installed. We got just a little sliver of ply installed on the left-hand side of the screen behind that servo capture section there. So that worked out good. Happy with that. All right, then if we look at the angle here, Nez is inspecting it for us, and we are bang on perfect. So that is awesome. Happy with that. The arm's not fully installed, but when that arm is pushed on all the way, it's perfect. So that's a good scenario here. I think that's going to work out well. When we put these servos in, we're going to tuck them all the way to the top of the surface, in this case, which is actually the underside. And I think we found the solution for the horizontal stabs. All right, and servo burn-in process begins. This is something we haven't done yet on any of the servos for this plane. So we're using HV69s from MKS on the two elevators and the wing, so 4 surfaces on the wing. On the rudder or vertical stab surface, we'll be using a low-profile KST servo, and again, saving a little bit of weight on that guy. And I don't have one handy, but we'll pull one out eventually and show you. So one thing we do on all of our servos here, watch your butt, Nez, is we put them through 990 servo cycles. So the reason we do 990 is because that's the max that our jetty box goes to. But we get that set up in the jetty box. It just goes through automatically. So you can see there the countdown. We've got 627, 6, 5. The distance is 500, which is the full travel. And our speed is 40. So you can turn this down to as slow as you want, or you can turn it all the way up to 90, 99, and the servo will travel as fast as it can possibly travel. So why do we burn in our servos? The reason we burn in our servos is if there's going to be a problem with the servo, we want it to show up in the beginning of its life. So before it actually ends up in the plane, A generalization would be that if an electronic device is going to fail prematurely, it usually fails in the beginning portion of its life. So we want to put this through a heat cycle, some movement cycles. 990 is a good amount. It takes about 20 minutes at that speed, and it's just a way to ensure that you're minimizing defective servos going into planes. Yes, we have had defective servos in the past. MKS has been 0. There's been other manufacturers that we've had defective servos out of the box. And as you go through this process, I just mark the servo with a check mark or a mark on the underside of the servo. So once this one's done, I'll get another servo hooked up on the jetty box, and then we'll get this servo working on installing in the surface. All right, so we're almost through cycling the servos. Those guys are all done. What is this? The right stab has its servo installed. Still need to put the arm in. Now, before we can put the arm on, we need to get this servo hooked up to the receiver. So that's a great time to make a new model, which we haven't done yet on this plane because there was so much to do in the building end of things. So we did make a new model. I just copied my blank model on my shop radio. We called it Glacial, of course, because that's what the plane is. And we've got some basic things set up. This is my default turbine model, but we will bind our receiver at this point and make some changes that we need to. So the receiver we're going to use is going to be the Rex 10. Now the reason we're using the 10 is we need a certain number of channels on this plane. So if you think about the number of channels we have 2 stabs, a vertical stab. We've got 4 on the wings, and that's it. So that's 7, plus we need a throttle channel, which is 8. So we need 8 channels for this aircraft. Now, the Rex 10 is kind of a cool setup for this versus using something like the Rex 12. So the 10 here, we've got 10 channels available, which is perfect. And we've got 2 battery inputs, which is perfect as well. And it's going to work out well with our Meson Evo BEC speed control because you've got your battery lead on one of them and you've got your EXT lead on the other one. So both of these guys are supplying power to the receiver. So one of them will be plugged into EXT, the other one will be plugged into one of the battery ports. And then, just for some redundancy, we'll add a 900 receiver in here, and that will go to our E1 port located on the Rex 10 receiver. So we'll only have one of the battery ports open on this guy, which is great. So that's going to be a good rock solid and light setup because this thing weighs almost nothing, as does that. All right, so we got our model set up here in the radio, so that's all bound and ready to go. Now we'll just go in and change our properties, right? So we've got model, basic properties, so we should be able to set everything up here. So on the wing type, let's see, maybe we've got 4 flaps, 4 ailerons. What we may do, there we go. So in this wing, we've got 2 flaps, 4 ailerons. So we'll use this wing type, but we won't use the 2 flaps, I think is going to be the best way to do it. So there we go, 4 ailerons, 2 flaps. Tail type, we've got 1 vertical and 2 horizontals, so that's correct. Engine count 1, gear servos is 0, gyro, no. So when you delete some of those things, it just gets rid of some of the menu items, right? So as far as control goes, flaps will turn off because we don't have flaps. Gear, these are all pre-programmed things in the default model. So we can actually just delete gear. We can delete flaps, maybe. Oh, we can't delete flaps, probably because we selected it in the wing type. So we'll just clear that out and get rid of our flap thing that makes it work. Brake, we were able to delete brake, and we can also delete the nose wheel. So there you go, super simple plane actually. So aileron, elevator, rudder, throttle, flaps. Let's see how it organized it. So we've got throttle, aileron, flap, flap, aileron. So let's change this out a little bit. So we'll keep throttle as channel 1, and then we'll go aileron 1, gosh, function assignments, no, servo assignments, there we go. So we've got throttle, aileron 1, we'll go aileron 2, we'll go aileron 3, we'll go aileron 4, and then we'll go elevator 1, elevator 2, and then rudder. So these designations for ailerons, what we'll do is we'll go aileron 1 is always our left, aileron 2 is always our right, and then we'll go aileron 3 is going to be left again, aileron 4 is going to be right. So we'll just segment those out to however our wings are going to work out on the plane. So maybe the lower wing, actually we'll do upper wing 1 is left, upper wing right is 2, lower wing 3 is left, lower wing right is 4. I think I said that right. So, and because this is our right elevator, so we're going to plug that into elevator number 2, and we're going to get our servo centered so we can put our horn on. All right, so we got both of our servo arms mounted, and I got the channel done here for one of the servo control arms. So sanded the little tabbies off the bottom there. You can see the difference. Added some texture. We'll drill a couple holes in there when we go to glue this in. But basically I ended up using our 1/8 bit and for the Dremel, sinking it as much as I could. I can actually go a little bit further, but sinking it down. And the reason for that is to make sure that when we put this in the slot to do the slot, we're not punching through the other side of the surface. That's kind of an important thing. And so yeah, I got that adjusted on this one. Have to do the same thing on this side. So just so you can see the difference here, it goes from looking like that skinny little slot that we did from the template to a wider slot. And the nice thing about the wider slot is we've got a little bit of adjustment here. You have to open that slot up towards the rear to make sure this sits properly. But we've got a little bit more room here to get this adjusted and angled and everything so it matches up with the servo arm perfectly. All right, so we got the gluing done on our horizontal stabs, and basically what you do at this stage is you just get those horns lined up with the servo arm. We've got our tape to remove still, and you just keep checking on it as the high saw kicks off. So it'll be about an hour, hour and a half. So I like to do this stuff if it's got some movement. We'll pull the tape off right now. And then what we do is just keep an eye on it until it's starting to firm up. Then what we can do is give it a last minute adjustment or a final adjustment and leave it be. Now I just bumped that when I took the tape off. It's another reason to keep an eye on those things. Okay, so tape's off. Now what I do is I look down that servo arm or the carbon arm, and we just get it lined up with the servo arm. So that is perfect. Good, so we'll come back and check on that in a little bit, and we just have to leave these horizontal stabs to rest. All right, so plugging away on the control arms here. So I got our scenario figured out. We're using some ball joints here, some smaller size ball joints with a 3mm threaded rod. So what I do is I get this kind of all sized up, set up, and then now we'll plug the servos into the receiver. We've got our surface taped off to the neutral or 0 position, so we're perfectly centered there, and we'll get this set up and perfectly set up to the center location on our surfaces. All right, so we got our surfaces all set up here, and they are wonderful. So we got lots of travel available. Also 0 play in the surface. That's a cool setup with those HV69 servos, and the ball joints and everything are very, very accurate. All right, so with our horizontal stabs done, we want to get our connection points completed here. So we've tucked the servo wire on the left one in all the way. So this is how we're going to be dealing with these guys. And what I've done is I held this up and marked the space forward of the wing tube and the structure. That's right by the servo lead there. So I put a mark there, so our servo connection needs to be in front of that mark for everything to work out well. The plane also has a cardboard tube that runs all the way to the back for the servo leads to come through. So it might be tricky to fish through, it might not, I don't know. So what we'll do first is we will open up a little slot here. I'm thinking what we will probably include is one of these guys here on each side, as long as they fit in the horizontal stab. So I'm going to figure that out. Otherwise, we may just glue our servo connector right to the skin or the surface, and that'll be a nice, clean, light setup as well too. So I'm going to figure that stuff out, and we'll come back and take a look. All right, so I got one of the servo connector holders installed. We went with the square ones, rectangle ones, and it looks like everything's going to be great with it. So one of the benefits of this setup is you've got this recessed pocket area here. Those connectors do actually have a bunch of room to sit in there, and once they're in there, there's plenty of space for it to move around. So that is going to work out good. I haven't looked at the path yet for the wires, so that's the next thing to take a look at. So if I take the file and just install it like that, and then if we take a look down the front of the aircraft, yes, Nez, I don't see it. So maybe we'll grab a piece of wire. Okay, so 2-foot piece of wire, just dangle that in there, and now I see it. Okay, that's good. So that's right in front of the cardboard tube. So that cardboard tube is right in the middle of the screen. I'll try and zoom in as much as I can on the left-hand side of the screen. And if you look way back in the center, you might be able to see the wire dangling down in the center of the fuselage. So that is great. That's a good path for everything. I'm happy with that. So there is our servo pockets for the holders, and there is our holders. So we've got them marked out with the signal lead, and now we're just going to get those glued in place. Before we actually glue them in place though, we want to just tuck our wires into the fuselage and get them run down the cardboard tube. All right, so I got my rigid wire installed, and if you look through the pocket there, you can see the wire is in the perfect spot. So that worked out beautiful. So now what we'll do is we'll feed the wires into our little loop there and hopefully be able to pull them all the way forward. All right, so the plugs are all done, installed. We've got them screwed in place rather than glued in place, so they're removable. And we ran those lines forward to the front here, and they are marked as well too for what is what. So I like to leave these leads long, so right now they'll reach to about here in the fuselage. Chances are our receiver is going to be back here somewhere, so we'll be able to size them appropriately. So now what we can do is, we don't really need to install our elevators yet, but we can start working on our rudder setup. So that, of course, is a pull-pull system using cables, and they go through the little slots there, and they will cross at the front. Now I think that should be fairly straightforward. I think running the cables is going to be the hardest part, but our servo mounts right there, quite straightforward. The kit does come with a carbon horn, so that's the first thing I'm going to figure out is what we're going to mount that carbon horn to. So we'll get that figured out, and then we will look at installing the rudder. All right, so looking at our servo horn setup here, this is a great design in my opinion for something like this. So you've got the carbon pull-pull setup. One side is recessed, the other side doesn't have the recess. So basically if we take this servo arm here and line up the holes on this guy, everything lines up perfectly. Now if we do the exact same thing on one of the round ones, kind of only fits together one way, but the holes don't quite line up perfectly, so they're just a fraction off. I would have rather used the round one, but it doesn't really matter at the end of the day, so we'll end up using this guy here. So I'm going to cut this arm down, and then we will see how it centers on the servo best. So obviously we've got 4 options how it sits on the servo, and we'll pick the option that is going to be as square as possible, and then we'll get the pull-pull setup installed on here. All right, so we got our servo plugged in, plugged that into our receiver, radio's on, figured out which direction is nice and square on the servo arm. Got it cut off, used symmetric 2mm hardware. That screwed very nicely into the carbon horn here, and just finished that off with a little bit of CA on there just to hold the screws in place even though they're nice and tight. And then now we can get this installed on the servo. And then of course we'll install our screw, and then always using Loctite, super important. Don't forget your Loctite. So now this servo is ready to go into the fuselage. Now if you look, there's that wood piece right there. I'm assuming that is designed for the rudder servo, and that's going to give the servo screws something to bite into, because the formwork that's in there is carbon laminated foam. So I guess you could install this on the underside, but the better place to put it would be on the top side. And the reason for that is if you put this on the underside, install the servo, there is a chance that your servo is going to make indents in the carbon laminated foam. So it is better, in my opinion, to mount that on top. I can't remember what the video shows from Lassie, but I believe that's how it gets installed. All right, so I got the pull cables installed, just ran them through the little slot that we made in one of the previous videos, let them kind of curl up. And then to grab them, use some of our wire here. This is the stuff we generally do all of our pulls with. It's just like fencing wire. So that's what I reached down there with, grabbed the cable and just pulled it through. And then we've just got it taped off for each wire. And I can't really show you, but obviously you're crossing your wires as well too. So the wires are all ready to go. Now what I'm thinking about doing is doing our servo end first, getting our servo installed. Then what we can do is we can power up the servo and we can get this side of our connection set up. All right, servo is installed. Everything worked out good. We just screwed that down, put a little bit of thin CA around the wood. So now the wood is also glued to the carbon, but didn't do that till the very end, so everything's lined up. Now those lines go back, they cross, and now at the rear of the plane, we've got excess amount of line, which is great. So it gives us options here. So what we're gonna do is we're gonna tape off our vertical stab at the top to be nice and square, just initially. And then we are going to get these lines run, circled back, and crimped with one of the little crimps that come with the kits. And while we're doing all that, we're gonna have the servo plugged in and powered on, so the servo is gonna be centered as best as possible. All right, so vertical stab, rudder surface is done. We've got nice tension on our cables, which is awesome. And without adjusting the servo at all, we are bang on in the center. So that is set up now, and we've got lots of travel available on that surface. And there's a shot of what the rudder looks like. So I'm going to reduce that travel a little bit in the servo menu. All right, guys, now I've been thinking about this, this rear section here since we did it, and I'm still not happy with it. This isn't a long-term solution. Probably will be okay, well, might be okay long-term, but the downside is as this moves, obviously, eventually this cable is going to start slicing through the carbon. So better solution is to do some hardware changes here. So what I've done is I think we'll still have enough cable here, but we're going to use a golden clevis, which is rock solid, one of the little adapters here for the cable, and this is how we're going to get things set up. So what I'm going to do is going to get this set up on each side. We'll basically repeat the exact same thing we did before, get it all tensioned and everything, but then we'll have some clevises and some rock solid attachment points here for the vertical stab. And there's our change system. So we've got basically the perfect setup here. So adjustable, we've got little locking nuts. These locking nuts are actually from Skymaster aircraft. So they're 440 locking nuts and they're really low profile rather than using an actual nut. So I like that. and much more long-term, durable, and adjustable solution. So easier to adjust this end than the other end inside the fuselage, but we've got adjustments now on both ends. All right, and that wraps up video 3 in the Nurila Glacial aircraft assembly, build, whatever you want to call it. We got progress obviously done on the tail. The tail section's done, ready to go. That feels good. Next video, we're going to start off with the wings. So the wing surfaces, 4 ailerons in the wings. I don't think those will be overly hard using the templates. We're going to get the landing gear mounted, the engine or motor mounted. Those are all pretty technical, detail-oriented things, just like everything we've done so far. If you guys weren't aware, we also have a podcast channel. So it's called the RC Air Experience. It's a completely separate channel. Me and my friend Anthony do it. The last 2 podcasts that we did, number 1 was with Martin Pickering.
And we hope you enjoyed the video, so like
and subscribe.
See you in the next one.
And the very last one we did was with Bert Garrison, who was the last SR-71 pilot. And we went into a ton of detail on him flying that aircraft and some pretty cool stuff. So encourage you to check it out. We talked to a lot of cool people on that channel, and definitely some pretty cool guests recently. So thanks guys so much for watching and supporting the channel, and we'll see you in the next video.